Hi students, today we are learning the topic is quadratic form. So what is the quadratic form definition and how to defining the quadratic form of the given matrix. Okay na? And also the matrix is converted to the polynomial and polynomial is converted to the matrix form. So that is our topic is quadratic form. Okay. First of all, see the definition of quadratic form. A homogeneous polynomial of second degree in n variables is called quadratic form, and that is equal to n variables means that is a one variable, two variable, or three variable up to so on. Any variables, any number of variables. The variables formed only second degree polynomial and also homogeneous. Homogeneous means in the polynomial, in the every term the degrees must be 2, that is called homogeneous. That is equal to a second degree homogeneous polynomial of variables is called quadratic form. See that here another one, an expression of the form summation I is equal to 1 to n, summation I is equal to 1 to n aij xij, and substituting here I is equal 1 to n, j is equal 1 to n. So aij means coefficient. Okay na? And in that coefficient is aij is equal to aji, and the term is equal. For example, a12 equal to a21, a13 equal to a31. The coefficients are must be equal of x1 x2 x2 x1 x1 x3 x3 x1, that is coefficients are equal, all are real also, is called a quadratic form in n variables x1 comma x2 comma up to so on xn. This explain చేస్తే మనకు there exists a polynomial in second degree of n variables x1 x2 up to so on xn. So that is equal to here the quadratic form corresponding to a symmetric matrix A. These are coefficients ఉన్నాయి కదండి, aij and a11 a22 a33 up to so on ann. Next one a12 a21, that all are coefficients. That coefficients formed a matrix. The matrix is must to be symmetric matrix because ఇక్కడ చూడండి aij is equal aj కదా, అంటే ఏమవుతుంది a12 a21 equal, a13 a31 equal, that is a23 a32 up to so on, all are equal కాబట్టి that is only symmetric matrix, real symmetric matrix. And this polynomial also can be write in the matrix form x transpose a into x. X transpose is matrix of unknowns కదా, unknowns means x1 x2 up to so on x, transpose అంటే row vector అవునా, into a is a coefficient matrix, that is a symmetric matrix, and x is the same unknown matrix, that is only column vector. So that is equal to, this is a polynomial form, this is a matrix form. This is called matrix form of the given quadratic form. Okay, so that is equal, where a is equal to already told, this is a symmetric matrix, all are coefficients a11 a12 up to so on a1n, a21 a22 up to so on a2n, up to so on an1 an2 up to so on. This is a coefficient matrix, and x is the matrix of unknowns, this is a column, and x transpose is also same matrix but row, x1 x2 up to so on xn. So the coefficient of xij is equal to ai aj plus aj, both are equal together, already I told this is a1 to a21. So that is example 2ij or 2j, both are equal but sum is equal to. Okay na? Next to coefficient of xi square is aii, and that is a diagonal elements, that is a11 a22 up to so on an, that is the coefficients of xi square, and a11 is the coefficient of x1 square, a22 is the coefficient of x2 square, up to so on ann is coefficient of xn square. అవి ఓన్లీ డయాగ్నల్ ఎలిమెంట్స్, ద కోఎఫిషియంట్ ఆఫ్ ది స్క్వేర్స్ ఆఫ్ ది సేమ్ వేరియబుల్ అండి. సో దిస్ ఈజ్ ద డెఫినేషన్ ఆఫ్ క్వాడ్రాటిక్ ఫార్మ్ ఇన్ n వేరియబుల్స్. Okay, that is a continuation. Next example, see that. Examples. Yeah, first example, this is a quadratic form. Q is equal to a11 x square. This is a quadratic form in single variable. X is the only single variable. This is the second degree polynomial and this is the a11 is the coefficient. Okay na, this is converted in the matrix form. So x is a variable unknown kada, that is equal to matrix x into matrix a11 అంటే ఓన్లీ సింగిల్ ఎలిమెంట్, సేమ్ మ్యాట్రిక్స్ వేరియబుల్ x into unknowns, దట్ ఈస్ ఈక్వల్ టు అజంప్షన్ దిస్ ఈజ్ x ట్రాన్స్పోజ్ అండి అవునా. ఇది మ్యాట్రిక్స్ A, దిస్ ఈజ్ x, దట్ ఈస్ ఈక్వల్ టు x ట్రాన్స్పోజ్ A into x. దిస్ ఈజ్ అ క్వాడ్రాటిక్ ఫార్మ్ అండ్ మ్యాట్రిక్స్ నోటేషన్ ఆఫ్ సింగిల్ వేరియబుల్. ఓకేనా. సో సిమిలర్లీ వి డిఫైన్డ్ ఇన్ టూ వేరియబుల్స్ క్వాడ్రాటిక్ ఫార్మ్. చూడండి, q ఈజ్ ఈక్వల్ టు a11 x స్క్వేర్ ప్లస్ a22 y స్క్వేర్ ప్లస్ a12 a21 ఇంటూ xy. అంటే xy కోఎఫిషియంట్ ఎలా తీసుకుంటాం మనం, yx xy సేమే కదా డిగ్రీ, x ఇంటూ y అండ్ y ఇంటూ x, ద కోఎఫిషియంట్ ఈజ్ కామన్, దట్ ఈస్ a12 a21. చూడండి ఇది కోఎఫిషియంట్, xy కామన్ తీసుకున్నాం, xy yx బోత్ ఆర్ ఈక్వల్గా తీసుకుంటాం అండ్ a12 a21 ఈజ్ ఆల్సో ఈక్వల్, యాడింగ్ బోత్. దిస్ ఈజ్ ద quadratic form in two variables. Your two variables are x, y. So matrix notation. So this is matrix of, this is x transpose, two variables x, y row. So and matrix A, this is matrix a11 a22 is the only diagonal element. చూడండి ఇవి diagonal elements. a11 is x square coefficient, a22 is a y square coefficient. నెక్స్ట్ xy కోఎఫిషియంట్ a12, దీనికి ఆపోజిట్స్ కంపల్సరీ అంటే సిమెట్రిక్ ఈక్వల్ కదా, a12 a21 ఇలా ఉంటుందని, ఇది ఫస్ట్ కోఎఫిషియంట్. ఓకేనా, దట్ ఈస్ ఈక్వల్ x ట్రాన్స్పోజ్ a ఇంటూ x. సో నెక్స్ట్ థర్డ్ వన్. సో థర్డ్ క్వాడ్రాటిక్ ఫార్మ్ ఇన్ త్రీ వేరియబుల్స్ x, y, z, త్రీ వేరియబుల్స్ క్వాడ్రాటిక్ ఫార్మ్, దట్ ఈస్ a11 x స్క్వేర్ ప్లస్ a22 y స్క్వేర్ ప్లస్ a33 z స్క్వేర్ ప్లస్ a21 ప్లస్ a12 కోఎఫిషియంట్ కామన్ కదా, xy సేమ్ ప్లస్ నెక్స్ట్ xz a13 ప్లస్ a31. అంటే ఫస్ట్ వేరియబుల్ థర్డ్ వేరియబుల్ అండి గుర్తుపెట్టుకోండి. xy ఇస్ ద ఫస్ట్ వేరియబుల్ సెకండ్ వేరియబుల్, నెక్స్ట్ ఫస్ట్ వేరియబుల్ థర్డ్ వేరియబుల్ ప్లస్ a23 ప్లస్ a32 ఇంటూ yz. నెక్స్ట్ yz మీన్స్ సెకండ్ వేరియబుల్ థర్డ్ వేరియబుల్. సో మళ్ళీ సేమ్ రిపీట్ అవే వస్తాయి కాబట్టి అవి కామన్ తీస్తున్నామండి. ఓకేనా, yx zx yz అన్ని సేమ్ కాబట్టి కామన్. సో ఇది ద మ్యాట్రిక్స్ ఫార్మ్ ఈస్ x ట్రాన్స్పోజ్ అంటే త్రీ వేరియబుల్స్ కదా, రో మ్యాట్రిక్స్. సో xyz ఇది x ట్రాన్స్పోజ్. సో 3x3 మ్యాట్రిక్స్ అండి, a11 a12 a13 a21 a22 a23 a31 a32 a33 ఇంటూ దిస్ కాలమ్ వెక్టర్ xy. చూడండి ఇక్కడ ఇవి డయాగ్నల్ ఎలిమెంట్స్, a11 a22 a33 ఈజ్ ద కోఎఫిషియంట్స్ ఆఫ్ x square y square z square. Next to a12 a21 is the coefficient of xy, a13 a31 coefficient of xz. Next to a23 coefficient of yz. అవునా, మనకి ఆర్డర్ చూసుకోండి, x స్క్వేర్ y స్క్వేర్ z స్క్వేర్, నెక్స్ట్ కోఎఫిషియంట్ xy, నెక్స్ట్ xz, నెక్స్ట్ yz. ఇంకా వేరియబుల్స్ ఉంటే సేమ్ ఎక్స్టెండ్ అవుతాయి. సో దిస్ ఈజ్ ద ఎగ్జాంపుల్స్. ఓకేనా, దిస్ ఈజ్ ఎగ్జాంపుల్స్ ఆఫ్ క్వాడ్రాటిక్ ఫార్మ్ అండ్ ఇట్స్ మ్యాట్రిక్స్ నోటేషన్. ఓకేనా, సీ దట్ నెక్స్ట్ వన్. సో నెక్స్ట్ డెఫినేషన్, లీనియర్ ట్రాన్స్ఫర్మేషన్. సో లెట్ q is equal to x transpose ax be a quadratic form and x is equal to py be the non-singular linear transformation. So in the quadratic form substituting x plus lo py, so that is equal to py transpose into apy is equal to y transpose p transpose apy. Observing here, this is a p transpose ap, this is one of the matrix B. B is a non-singular matrix also where B is equal to P transpose AP. So that is equal to the new form Y transpose BY. Y transpose BY is called linear transformation of the given quadratic form X transpose AX under a non-singular transformation. This is also X is equal to PY is one of the non-singular transformation. Under mapping this one, the given quadratic form is linear transformation and B is also symmetric. ఇక్కడ A is symmetric కదా, అంటే దీని ప్లేస్లో న్యూ వేరియబుల్ తీసుకున్నాం అంతే. సేమ్ బోత్ ఆర్ సేమ్ ఉంటుంది. అక్కడ quadratic form, this is a quadratic form, both are same, but changing is variable changing, but form is the same. ఇక్కడ B is a symmetric, ఇక్కడ A is a symmetric, both are same. So that is a given quadratic form is called both are linear transformation. Okay, this is a definition of linear transformation. So next definition, rank of a quadratic form. And how to finding the rank given quadratic form. See that the rank of the coefficient matrix A is called the rank of the matrix of quadratic form X transpose AX. అంటే దట్ ఈజ్ ఈక్వల్ టు మనకి ర్యాంక్ ఫైండ్ అవుట్ చేయాలంటే కోఎఫిషియంట్ మ్యాట్రిక్స్ ర్యాంక్ ఫైండ్ అవుట్ చేయాలంటే డూ ఫైండింగ్ ద ర్యాంక్ ఆఫ్ ది కోఎఫిషియంట్ మ్యాట్రిక్స్. దట్ ర్యాంక్ ఈజ్ ఆల్సో సేమ్ యాజ్ గివెన్ quadratic form, but coefficient matrix is of the given quadratic form. Quadratic form rank find out cheyalante do finding the rank of the coefficient matrix. The rank is the same. So the and also the number of non-zero eigenvalues of A and another one. If finding the eigenvalues of given matrix A, the number of non-zero eigenvalues is called rank of the given quadratic form. Both are same only. Rank of the matrix A is also rank of the quadratic form, and another one, then after finding the eigenvalues of A is the coefficient matrix. The number of non-zero eigenvalues is also called rank of the quadratic form. So if rank of A is less than n is equal small n, order of A n. In case rank of less than order of A n, that is det A is equal 0, then the quadratic form is singular. And the rank of A is less than, also number of unknowns, both are same, order less than అనుకోండి, or det A is 0 అయింది అనుకోండి, rank the quadratic form is must be singular. Det A is not equal 0, the quadratic form is non-singular. This is one of the definition of rank of quadratic form. So next one, canonical form or normal form. This is important definition. Canonical form or normal form of the given quadratic form. So see the definition. Let Q is equal to X transpose AX be a quadratic form of rank R and orthogonal transformation X into PY. This is an orthogonal transformation only. P is one of the model matrix already we told in the previous lectures. That is a unit tool. So X is equal to PY is the orthogonal transformation which diagonalize A. That is D is equal to P transpose AP. ఇక్కడ P is a non-singular matrix, that is model matrix. And how to finding model matrix? P transpose is the orthogonal matrix. P is the orthogonal matrix. P is the form of the eigenvectors whose columns are eigenvectors. Each eigenvector is normalized eigenvector. There is a model matrix x1 x2 up to so on xn. Each eigenvector is normalized eigenvector. That is a P. Next P transpose finding. P transpose AP is getting the diagonal matrix. So D is the diagonal matrix of the matrix A. So then using this property, transform the quadratic form Q to a new form summation I is equal to 1 to R lambda I into y I square, that is sum of R squares, and only the new form is only sum of the same variable squares. And a product of is eliminated, deleting, and xy, yz, zx up to so on. All product terms are eliminating, that is deleting. Only we getting the form of the coefficients of x square plus y square plus z square, and a new form assumption, that is coefficient of y1 square plus coefficient of y2 square plus coefficient of y3 square plus up to so on. That is form is called canonical form or normal form. The new form assumption y transpose d into y. Here y అనేది matrix of new unknowns and d is the diagonal matrix of given matrix. What is the diagonal matrix here? Assumption maybe eigenvalues of A or any other one. So using the orthogonal transformation method, the diagonal matrix whose diagonal elements are must be eigenvalues. So this new quadratic form containing only the squares of yi, and that is y1 square plus y2 square, y3 square up to so on. That is called canonical form or normal form or sum of squares form of the given quadratic form. This is a new form only. Okay, na? This is a canonical form of quadratic form. So that is equal note. This is one of the note. The number of non-zero terms in canonical form a quadratic form is rank of quadratic form. This is also one of the definition only. Rank of the quadratic form is rank of the matrix A is equal to the rank of the quadratic form. Another one, the number of non-zero eigenvalues of A is also rank of quadratic form. This is another one. When the quadratic form is converted to the normal form or canonical form, then in the canonical form, the number of non-zero terms in the canonical form is also called rank of given quadratic form. This is the rank of quadratic form and canonical form. Canonical form converted, we have three methods only. This is using any one method. So that is a converted, the new form. That is the only sum of the squares of the same variable. That is called canonical form. Okay. So next definition, index. Index of quadratic form. See the definition. The number of positive terms in the canonical form is called the index of the quadratic form and is denoted by P. And when the given quadratic form is converted to the canonical form, in the canonical form, the number of positive terms is called index of the quadratic form and is denoted by P. Or another definition, the number of non-zero positive eigenvalues of coefficient matrix of the quadratic form is called index of the quadratic form. This is another definition. మనకి canonical form convert చేసుకుని find out చేయొచ్చు or using the eigenvalues of the coefficient matrix. The same non-zero positive eigenvalues is called index of the quadratic form. So that is equal. Next definition, signature of quadratic form. See the signature. The difference between the number of positive and negative terms in the canonical form of the quadratic form is called signature of the quadratic form and is denoted by S. And in the canonical form, after converting canonical form, the difference between positive and negative terms is called signature. And also another one in the another terms, in the another form, the difference between positive eigenvalues and negative eigenvalues is also called signature of quadratic form. That is the difference between positive eigenvalues, that is non-zero positive eigenvalues minus negative eigenvalues, that is called signature. It is denoted by S. If the index is P and total terms are R, then the P is the number of non-zero terms here. In the non-zero terms, only positive terms is S. So remaining R minus P is the remaining is the negative terms here. Total R terms, R is the total numbers, total non-zero terms అవునా, అందులో p is the positive terms, remaining negative terms means r minus p కదా. అంటే total signature is equal difference between p is the number of positive terms minus r minus p is the number of negative terms, that is equal to 2p minus r. This is the signature of quadratic form. Okay, this is the index and the signature. So next one, next definition, value class or nature of a quadratic form. So value class defined in five types and 5 categories. We define nature of the given quadratic form. Okay, see that first of all, let given q is equal to x transpose ax be a quadratic form in n variables x1 x2 up to so on xn, and r be the rank and small p is the number of positive terms, that is the index in the canonical form of q. See that first one, if all terms in the canonical form are positive only, then the nature of the quadratic form is positive definite. If all terms in the canonical form are only positive only, అంటే non-zero positive, only positive, the nature is positive definite. Or another one, if eigenvalues of the coefficient matrix of quadratic form are positive only, then the nature of the quadratic form is positive definite. This is also another definition. If all eigenvalues of coefficient of matrix of quadratic form are positive only, that is non-zero positive, then the nature of the quadratic form is positive definite. Next, second one, if all eigenvalues of coefficient matrix of a quadratic form are positive and at least one eigenvalue is 0 only, then the nature of the quadratic form is positive semi-definite. In the canonical form, all terms are positive and at least one term is 0. And also another one, if the all eigenvalues of coefficient matrix must be positive and at least one is 0, that is the nature of the quadratic form is positive semi-definite. This is the two types. So remaining here, so third one, if all terms in the canonical form are negative only, then the nature of the quadratic form is negative definite. And that is in the canonical form all terms are negative only, that is non-zero negative, then the nature of the quadratic form is negative definite. Or another one, if all eigenvalues of coefficient matrix of quadratic form are negative only, then the nature of the quadratic form is negative definite. It is also same only. All eigenvalues must be non-zero negative, all are negative, then the nature is negative definite. Next, fourth one, if all eigenvalues of coefficient matrix of quadratic form are negative and at least one eigenvalue is 0 only, then the nature of the quadratic form is negative semi-definite. That is equal to all eigenvalues must be negative and at least one 0. At least one, more than one zeros maybe, but at least one 0 and all negative, then the nature of the quadratic form is negative semi-definite. And also in other words, in the canonical form, all terms are negative and at least one term is 0, then the nature is negative semi-definite. Okay, now this is the fourth one. Next, fifth one, if all eigenvalues of coefficient matrix of quadratic form are positive as well as negative, then the nature of quadratic form is indefinite. And all terms in the canonical form are positive as well as negative, అంటే combined negative values and positive values exist అని అనుకోండి. The nature of quadratic form is indefinite. అంటే ఐగన్ వాల్యూస్ కూడా సేమ్, అంటే పాజిటివ్ ఐగన్ వాల్యూస్ అండ్ నెగిటివ్ ఐగన్ వాల్యూస్ ఎగ్జిస్ట్ in the coefficient matrix, then the nature of the quadratic form is indefinite. So this is the definition of quadratic forms and some other definition of quadratic form and canonical form and basic definitions all. Okay, so thank you. For more videos please do subscribe my channel, like and share it. Thank you.